Welcome back. In this video, we'll walk you through how to set up calibration rules in the system. To get started, simply search for calibration, and you'll see all the related applications available for configuration. In this session, our focus is specifically on calibration rules, which play a crucial role in defining and governing the entire calibration process. These rules determine how different equipment types should be calibrated and help ensure each one follows the correct procedures and standards. The calibration rules setup begins with a system-generated calibration rule ID. From there, you can assign a meaningful name to the rule, something like backlight kit calibration, SEO calibration, or any name that reflects the procedure you're defining. You'll also choose how the result assessment should work. This can either be automated or manual. If you select automated assessments, the system will evaluate the calibration outcome on its own. Based on the measurement inputs you provide, it will determine whether the equipment has passed or failed. This helps ensure consistency and reduces manual decision-making. Within the rule setup, you'll see a few important sections. The first is reference values. These are your expected or standard values, the benchmarks you want to measure against. For example, you might enter the minimum required intensity or the standard output reading. These fields act as the baseline for comparison during the calibration. The next section contains measurement parameters or actual values. These are the values that will be recorded during the calibration process. The system compares these against the reference values to determine performance. The good part is that these fields are fully configurable. There's no fixed format. You can adapt them to match your technical requirements. For example, in the AC yoke calibration rule, the reference section might include details like the method used, leg spacing, or the weight of the yoke, whatever parameters are essential to that specific calibration process. In short, the system provides a flexible structure that allows you to define calibration rules exactly the way your procedures require. In this setup, we're using just one reference column, although depending on the calibration rule, you may not need to use the reference section at all. For example, in the AC yoke calibration rule, only the first reference column is active because it defines the method, while the other two columns remain unused. After that, we define the measurement values. These are the actual readings that the technician will enter during the calibration process. They represent the real-time measurements recorded for that piece of equipment. For instance, if the required leg spacing must fall between 2.5 and 3.5, the value entered during calibration must stay within that range to pass. The same applies to weight, where the acceptable range may be between 4 and 6 pounds. If you need more measurement parameters, you can simply activate additional rows using the checkbox. Each one creates another field for you to configure. You can add as many measurement criteria as the equipment requires. The reference section is intentionally flexible. You can use it to define acceptable ranges, technical limits, method notes, or any criteria that need to be validated during calibration. Once all reference and measurement details are set up, the next step is to configure the report settings. Here you'll enter the calibration certificate report code. This is crucial because different types of equipment may each require a unique certificate format. The report code tells the system which layout to generate. You can also assign a report title, add reference information such as quality standards or process notes, and specify a version number if applicable. These settings ensure that every calibration certificate is produced in the correct structure for that equipment type. In the next part of the process, we move to the results section. This is where the error values are defined, either entered manually by the user or captured during the calibration activity. These error values serve as important input parameters that contribute to the overall calibration assessment. In total, these parameters are categorized into 3 groups: reference value parameters, measurement value parameters, and error parameters, each with 3 fields available. Altogether, these 9 core parameters form the foundation of your calibration criteria and allow you to structure different types of assessments based on the equipment being calibrated. You also have the option to add remarks, which is helpful when you want to include guidelines or instructions on how this calibration rule should be used and in what situations it applies. Additionally, you can enrich the rule by assigning tags, specifying the standards followed, adding measurement notes, documenting testing conditions, or including performance details. These fields are flexible and can be customized to capture any specific information required for the equipment or the calibration process. They also support the generation of detailed and accurate calibration certificates. This completes the basic setup of the calibration rule. In the upcoming videos, we'll create more calibration rules and demonstrate how different types of equipment require different calibration approaches. You'll see how each parameter can be configured depending on the technical requirements of the equipment. That's all for this video. Thank you for watching, and we'll continue with more calibration configurations in the next session.